My name is Rachel Jones. I'm a certified industrial hygienist and professor at the University of California, Los Angeles Fielding School of Public Health. This is selecting an occupational exposure limit. OSHA permissible exposure limits are readily available on the OSHA website in tables Z1, Z2, and Z3. In recent years, OSHA has been publishing annotated tables that have the OSHA PELs, as well as the California OSHA PELs and the NIEHS RELs. The annotated tables also have a link to the ACGIH website listing the TLV. Industrial hygienists working in states that have state OSHA programs, such as California, should find the PELs promulgated by the state OSHA program, as they may be lower than federal OSHA PELs. The module learning objectives are to differentiate among the various types of occupational exposure limits, to identify the predominant authoritative organizations that set occupational exposure limits, and to align occupational exposure limits and occupational exposure scenarios. OSHA permissible exposure limits are readily available on the OSHA website in tables Z1, Z2, and Z3. In recent years, OSHA has been publishing annotated tables that have the OSHA PELs, as well as the California OSHA PELs and the NIEHS RELs. The annotated tables also have a link to the ACGIH website listing the TLV. Industrial hygienists working in states that have state OSHA programs, such as California, should find the PELs promulgated by the state OSHA program, as they may be lower than federal OSHA PELs. Safety data sheets will typically include all the relevant OELs in Section 8 about exposure controls and personal protection. The OSHA Hazard Communication Standard requires this section to include OSHA permissible exposure limits, ACGIH threshold limit values, and any other exposure limit recommended by the chemical manufacturer, importer, or employer preparing the data sheet. The NIEHS Pocket Guide, in addition to containing chemical and physical properties, also lists the OSHA permissible exposure limits and the NIEHS recommended exposure limits. The ACGIH threshold limit values are usually reported in safety data sheets, but a comprehensive catalog is available in the TLV's and VEI's booklet, which is published annually by the association and is now available digitally through the ACGIH Data Hub. There is also a link to the TLVs on the OSHA annotated table. When there are multiple OELs from different organizations for the airborne chemical concentration that have the same exposure duration, picking the lowest one is generally a health protective strategy. When choosing amongst the OELs, it is important for the industrial hygienist to document why one OEL has been chosen over the others, particularly when the selected OEL is not the lowest OEL. This table shows the 8-hour time-weighted average OELs for the chemical acetone as of November 2022. Note that the OELs differ for the different agencies. In California, the California OSHA PEL of 500 parts per million would be the regulatory limit, which is lower than the regulation from federal OSHA, which is 1,000 parts per million. It's important to think about why these OELs might be different. Two reasons may include consideration for technological and economic feasibility in setting the OEL, or the date when the limit was developed. Often, newer information leads to lower limits. It is not uncommon for a chemical to have OELs for multiple exposure durations. The table shows OELs for acetone, where the California OSHA has permissible exposure limits as an 8-hour time-weighted average, short-term exposure limits, and sealing limits. It's important to recall that the exposure duration of the OEL reflects the health effect, and that sealing and short-term exposure limits typically reflect concern about acute effects like irritation. Thus, the industrial hygienist might want to use multiple OELs with different exposure durations. Assessing compliance with OELs of different durations, however, will often require the industrial hygienist to use different sampling strategies to capture both shift duration average exposures and short-term or peak exposures. This choice of or prioritization of one OEL duration over another may depend on how the chemical is used in the workplace. For example, if the chemical is used infrequently but in a well-defined job task, it may be reasonable to prioritize a short-term or ceiling exposure limit assessed by exposure measurements collected during the job task of concern. Such data may demonstrate the exposure is below the short-term limit, and it may be possible to infer that the 8-hour time-weighted average exposure will also be below the OEL. There are a number of ways that aspects of OELs can influence industrial hygiene practice. Duration of the OEL is one factor. Whether the OEL is an 8-hour or short-term exposure limit influences the exposure assessment strategy that will be used to assess compliance. For example, a short-term OEL may lead the industrial hygienist to use real-time samplers or collect integrative samples over 15-minute periods during a job task when the chemical is being used. On the other hand, an industrial hygienist might collect shift duration integrative samples if the OEL is an 8-hour time-weighted average. Notations with the OEL can inform the selection of personal protective equipment, such as the need to use gloves or other barrier protective devices when the OEL includes a skin notation. Notations may also heighten awareness for the industrial hygienist about serious health effects such as sensitization or carcinogenicity. The health effect that is the basis of the OEL can indicate to the industrial hygienist the need to prioritize the elimination or substitution of the chemical so as to avoid a serious health effect. Or the industrial hygienist can adapt their exposure measurement strategy to collect more personal breathing zone samples for carcinogens so as to ensure exposures are below the OEL for these hazardous chemicals. The organization setting the OEL indicates whether the OEL is a regulatory requirement or represents a recommendation for best practice. Employers in the United States must comply with OELs set by OSHA, but may choose to benchmark exposures in their workplace against other, lower OELs. This image from the CDC Public Health Image Library is hopefully a historical artifact, but it illustrates a job task where selecting and applying an OEL is vividly relevant. In 1969, when this photo was taken, mosquito eradication in the United States involved widespread application of pesticides, including DDT. Pesticides are still used to eradicate mosquitoes in the United States and globally, but hopefully the task doesn't look like this anymore. After identifying the chemical being used, the OEL or OELs can be identified. For example, if the chemical is DDT, the ACGIH threshold limit value is 1 milligram per cubic meter as an 8-hour time-weighted average, and there is no short-term or ceiling exposure limit. From this picture, it's not possible to know how much time the worker spends doing this task during the work shift. The size and density of the pesticide cloud, however, suggests that there is likely value in identifying a short-term exposure limit that defines the maximum level of exposure that should occur during the pesticide application itself. For DDT, however, no short-term limits exist. Depending upon the pesticide, the OEL may have a skin notation. For DDT, the ACGIH has not assigned a skin notation, but the organization did assign skin notations for other pesticides commonly used during this time period, including paraquat and parathion. If the pesticide can be absorbed through the skin, a biological OEL may be appropriate because it reflects exposure through inhalation and dermal routes. Such notations would suggest that personal protective equipment should be worn to prevent dermal exposure. Today, a worker performing a task like this shown in the photograph would probably be wearing gloves, fluid-resistant coveralls, goggles, and a respirator, and would be applying the pesticide with an applicator that did not generate such large clouds of aerosols. To conclude, there are different criteria upon which to select OELs, but the most important element is to select and apply OELs in ways that protect the health of workers and to document your decision-making. Some of the materials referenced in this presentation are shown here, including websites for the ACGIH Data Hub and the OSHA annotated tables.
This lesson has been created by the Interdisciplinary Training, Education, and Research Activities for Assessing and Controlling Contaminants from Emerging Technologies Program, a collaboration of the University of Minnesota School of Public Health, the University of Iowa College of Public Health, and the University of California, Los Angeles Fielding School of Public Health. Funding for InTERACCT is provided by the National Institute of Environmental Health Sciences of the National Institutes of Health. The content of this lesson is the sole responsibility of the developers and does not necessarily represent the official views of the National Institutes of Health.